Welcome back. Dependent and independent events in probability. That's the lesson for today. So here is the definition. Let's talk about that. An event is independent of another event if the probability of the first event is not affected by the existence of the other event. That doesn't matter if it happens, the other event, or doesn't. That's called independent, okay? And whenever you have a setup like that, you can write it as probability of A and B when they're independent is the first probability you multiplied by the second probability of the event that's happening. Now, what is the dependent event? Well, dependent event, well, it's not a cheeky thing that I wrote here, opposite of the independent events. If the existence of the other event influences the probability of the first event or vice versa, that means that we have a dependent event, and that's a different kind of a calculation that we have to deal with. Now, let's go through an example, and that makes it more clear. So we have a coin is tossed and a die is rolled. Or getting a tail on the coin and a 1 on the die considered to be an independent event. Well, think about that. So I'm tossing a coin, I'm going to get a tail or a head, right? So the probability of getting a tail out of the tossing the coin is 1 over 2. Does this probability depend on tossing a die and getting a 1, which is 1 out of 6? Will the probability of the second event depends on the first event? No, it doesn't really matter what that is. So it doesn't really affect the probability of first one. So in this case, when we have the setup like this, where the one event doesn't influence the probability of the other event, we call that independent events. And if you want to calculate the probability of the total thing that has happened is 1/2, you multiply it by 1/6, which is going to be 1/12. That's the probability of the entire thing happening. All right, but they are not influencing each other's probability or event at all. Now let's look at another example. This example is, imagine you have a small bag with 5 Smarties, yummy, that's my favorite by the way, with 3 red Smarties and 2 yellow Smarties. When I have Smarties, I tend to collect the same colors. I don't know about you, but that's what I do. Anyways, that's a side point. So we have 3 reds, 2 yellow Smarties, and the question is, event 1 is that you pick one Smarties and eat it. Okay, randomly. You just pick one and eat it. And let's suppose the probability of the picking a red one is what? What is the probability of red one? You pick a red. Well, there are total is 5. We got 3 and 2 is 5, so it would be 3 out of 5. That's the probability of picking a red Smartie, okay, on the first try. Okay, now the second event is that, so you eat it. So you pick it, you eat it. It's done. Is now it is over. Now the total number of Smarties in the bag is 4, and regardless of what that Smartie is. Now you pick a second Smartie. Now, how many do you have in the bag? Well, we have 4 in the bag now, okay, because one we ate. Now let's look at this question. What is the probability of picking another red? How about yellow? So there are 2 questions here. So now you're looking at the second Smartie you're going to pick, and then now what is the probability of you pick another red? Well, it has to do with what was happening the first time we pick our Smartie. If the first time that we did, so if event, the first event, event 1, we actually did pick a red Smartie, okay? We actually did pick that. That means now there are not only 3 red Smarties anymore, there are only 2. So we know that. So will be the probability of picking a red will be 2 out of 4. That means it will be 1/2. That's the probability of picking the second red, or 2 I'm going to call that, okay, which is 50%. But then what if it wasn't? So how about if it's yellow? So let's think about this. Let's suppose that our first event, so if event 1, we didn't pick a red Smartie, okay? Let's suppose we didn't. That means now if you want to choose the second one and pick up red, we'll have 3 out of 4. Now the probability is 75% because we didn't pick. Well, that should say 75%, not 0.75%. That means that we didn't pick a red Smartie the first try. That means we didn't reduce the red Smartie number here, so 3 stays the same, but we took obviously 1 yellow, right? That's what it means because we picked it and we ate it. So the total is 4. So out of the 4, 3 of them is a red Smartie. Now the probability is 75%. So there are 2 possible answers based on the first event, right? And then we can talk about how about yellow. Well, again, the same thing happens with the yellow, and I'm going to leave you with that. But the same idea. What if the first one was yellow that you picked? And if the first one was yellow, the answer for that one will be 1. So the first one yellow, then you will have only 1 yellow left. So you will have 1 out of 4. That's the probability, or 0.25 or 25% probability, okay, if that happens. But if the first draw, the first pick was not a yellow Smarties, so if it wasn't, well, that means it was red. That means we still have 2 left out of the 4. And now we're going to have 0.5 or 50% probability of picking a yellow Smartie in a second round. So in this case, we know that this event depends, the second event depends on the first event, and the first event will influence the second event. And we call this dependent event in probability. And in this case, everything doesn't have a specific formula, but what it is that you have to include everything that can happen. Okay, so and then you have to have the calculation based on that, because the total number, the sample number will change, and also the number of the expected events will change. Okay, so that's what I was going to talk about. That's the dependent and independent event. I hope you found this useful. Continue checking out the next video on this series and probability. I'm going to continue with that. Until next time.